Okay, so let's talk about section 3.4. So 3.4 has us figuring out some things about percentiles and quartiles to figure out the 5-number summary and the box plot. Okay, so just to recap where we were, last time we met, we finished talking about standard deviation, and we said spent a lot of time talking about these brands of outdoor paint. They were tested to see how long they lasted before fading, and here were some results. We calculated standard deviation and mean of this data and did a few things to that. But what if there was one of these brands, one of these paint samples that instead of being 220 was 200? That would really strongly influence all of these. So if we had a whole bunch of data points here and some outliers, because standard deviation takes into account every single data point equally, it gives everything equal weight, it's really sensitive to some outliers. And actually, I'm going to even take a step further than that and say it's more sensitive to an outlier than it is to something close to the mean. Because if you look at their standard deviation formula, it's the square root of the sum of each of the values minus the mean squared divided by the number of samples minus 1. Right here, this is the distance between the sample, so here it would be 10, minus the sample mean, and then you take that distance and you square it. So things that are really close to the mean say that this difference is maybe only 1. 1 squared, that's just 1. What if this distance is like 150? Now you have 150 and you've squared 150. So it actually, standard deviation becomes really sensitive to outliers. And that's a problem with standard deviation. It's a limitation of it. So standard deviation is sensitive to a few extreme outliers. Some other descriptive measures that are going to tell us about the spread aren't. And ones that are based on percentiles aren't sensitive to extreme measures. So we've already talked about one measure of center that isn't sensitive to outliers. Instead of talking about the mean is sensitive to outliers, we talked about the median. So now we're going to kind of add a little bit more on the median and how we can use things like the median to describe the spread of the data in a way that isn't sensitive to some outliers. So that's the topic of section 3.4. Okay, so the resistant measure that we are going to spend the most time talking about is this idea of quartiles. So if you want to imagine taking, if you had a relative frequency diagram of a uniform distribution of things. So it says that every single bin here has an equal chance, equally likely to happen. So this would be some sort of a plot where we had relative frequency here on the y-axis, and this would just be our x data. We could bin this data so that 25% of it was here, 25% of it here, 25% of it, and 25% of it. Another way to think about binning this data is, what if our distribution is not horizontal like this, but bell-shaped? Just to kind of pull an example from the previous section, right here was our bell-shaped distribution. So our bell-shaped curve looked like this for what the distribution was. And here is the data. And so we could set some numbers, and we're going to call those numbers quartiles, so that 25% of the data, sort of we could look at the bottom 25% of the data, the middle to 25% of the data, and the top 25% of the data. And that's what quartiles are. Okay, so we could also look at right-skewed data and left-skewed data. And now you can see that 25% of the data has this really long range in a right-skewed data point. And now in a left-skewed data, 25% of the data has this really long tail in the left direction. So we're going to spend some time in the next 15 or 20 minutes figuring out how to compute these numbers, these Q1s, Q2s, and Q3s. So Q1 is called the first quartile. That is the number that divides the bottom 25% of the data from the rest of the data, from the top 75%. So here is 25% of the data falls to the left of Q1. Up here, here's Q1, 25% of the data falls to the left of Q1. Up here, 25% of the data falls to the left of Q1. The second quartile is the number that divides the bottom 50% of the data from the top 50% of the data. We already have a number, a word for that. We call it the median. Right? We sort all of the numbers and we find the number that is in the middle, where half of the numbers are above and half of the numbers are below in our table, and we called that the median. So Q2 is the median of the data. And Q3 is the third quartile. This is the number that divides the bottom 75% of the data from the top 25%. So let's do an example, find that number. Here's an example from your book. The TV weekly viewing times for 20 people who were sampled, and this is the number of hours per week that they spend. So the question is, let's find what's called the 5-number summary and the IQR for this data. We haven't defined either of those yet. So what's the 5-number summary? Here's the 5-number summary. It's 5 numbers that summarize the data. It's a very well-named vocab word. We have the minimum and the maximum. And we have the numbers for Q1, Q2, and Q3. And then we're also going to do the interquartile range, which is sort of the difference between the 75th percentile, the third quartile, and the 25th percentile, the first quartile. So this is going to sort of give us an idea of the range of the data. And here's going to be our 5-number summary. So that's what we want to find. So your book has a pretty nice set of steps that they want you to follow to determine the quartile. So we're going to follow these steps. You're going to arrange the data in increasing order. So start with the smallest number, go to the biggest number. Find the median of the data set. That value is the second quartile. Then we're going to divide the data into 2 halves, the bottom half and the top half. And then we're going to find the median of the bottom half of the data. That's Q1. We're going to find the median of the top half of the data. That's Q3. And then we'll write all of our numbers at the end. So let's do that with this data. So here are my 20 data points. And I have very conveniently already sorted that. In class, I will give you some tips on how to do that quickly on a computer, because it can kind of be a pain to do any number of data points that's more than 5 or 10 data points by hand. So, yeah, I've taken this data. Smallest number was 5. It goes all the way over here. The biggest number, 66. Dude watches a lot of TV, 66 hours a week. Man, that's more than a full-time job. I guess these people have full-time jobs as watching TV as well. I don't know who they are. I have too much things to do in my life. Okay, so we're going to follow these steps. So we arrange the data in increasing order, and now we're going to find the median of the entire data set. That value is Q2. So let's do step 2. Find the median of the entire data set. I start on the outside. There's my first. There's my first. There's my second. There's my third. Fourth. Fifth. Sixth. Seventh. Eighth. Ninth. 10th. So these 2 numbers are the middle of the data. We have an even number of data points, so there's no one number that is the median of our data. So the median of the data with the 2 numbers in the middle is the number between them. So the median is 30.5. Okay, next we want to find the median. Step 3, which I've skipped over here, is divide the ordered data set into 2 halves, the bottom half and the top half. If the number of observations is odd, include the median in both halves. Our number of observations is even, so we're not going to do that. And we're going to divide the data into a bottom half and a top half. So that's step 3. Here's our bottom half, here's our top half. Now, step 4 and 5, find the median of the bottom half, that's Q1. Find the median of the top half, that's Q3. So the median of the bottom half, I have 1, 2, 3, 4, 5. There's my 2 numbers. that are in the middle. So the median of these 10 numbers here is whatever is the number between 21 and 25. And the median of these 10 numbers, 1, 2, 3, 4, 5, is whatever is the median, whatever is the average of 35 and 38. So those are our quartiles, and now we need to do the 5-number summary. I guess I should actually write this. So 21 divided 21, the halfway between 21 and 25, that's 23. So Q1. And halfway between 35 and 38 is Q3, and that is 36.5. Okay. So our 5-number summary our 5-number summary is the minimum, the maximum, and the 3 quartiles. So I have, this is 5, Q1, which I found to be 23, Q2, which is the median, 30.5, Q3, which is 36.5, and the maximum, which was 66. Our inner quartile range is Q3 minus Q1. So that is 36.5 minus 23. Oh man, I'm not going to pretend like I'm good at this in my head, and I forgot my calculator. So whatever those two numbers subtracted is the inner quartile range. What is that, 10.5? I think it's 10.5. I feel pretty good about that. So this inner quartile range is useful because it's saying that this is the difference between the 75th percentile and the 25th percentile. In other words, 50% of the data falls in this range. So 50% of the data lies between 23 and 36.5. So half of the people that were sampled watched between 23 and 36.5 hours a week. So half of people sampled watched between 36.5 and 23 hours.